Hi, Math 30s. So we're moving on to the last lesson in polynomial functions. And in this lesson, we are going to review graphing from the last lesson, which was lesson 8 in your workbook. And then I'm going to introduce one last new concept. This lesson is going to be completely from your note package. So what I want you to do is I want everybody to take out their note package and to flip through your note package. And we're going to be doing 4 questions in the note package. So find the question that has this slide on it. And then what happens is the homework is going to be from lesson 9 and 10 in your workbook. So we will not do the workbook class examples. We're going to do these 4 class examples instead. Okay, so the first two examples we're going to do will be reviewing essentially and putting everything together that we learned in lesson 8. So hopefully this question for the most part will be a review. So the first thing, it says sketch the graph of this polynomial function here, and it gives it to us in factored form. It's always nice when it's in factored form because I could easily look at the factors and get the zeros from these factors. So when we're graphing it, without first putting it into our calculator, let's see how much we could get without putting this into our calculator. The first step that you always want to do when you're going to be graphing is you always want to figure out what the x and the y-intercepts are. So the x-intercepts are from setting each factor equal to 0, right? So if I was saying, okay, what is the x-intercepts of this graph? This x-intercept right here would be an x-intercept of -1. Then I would go to this factor, and that x-intercept would be 1. I go to this last factor, it has an x-intercept of -2. So let's go over here, and let's put in our x-intercepts. So we've got an x-intercept of -2, an x-intercept of -1, and an x-intercept of 1. The next thing that we have to be able to do is we have to be able to figure out what the y-intercept of this graph is. And I want you to be able to figure this out without punching it into your calculator. So you're algebraically figuring out the y-intercept. And we've done this in Math 10C and 20-1. If you want the y-intercept of a graph, what you do is you let x equal to 0. So if I give you a polynomial function and I say algebraically solve the y-intercept, every time you see an x, you're going to put in a 0. So algebraically solving the y-intercept, it is going to be h of 0 is equal to, okay, so let's figure out what h of 0 is. 0 plus 1 is 1 squared, times 0 minus 1 would give me -1, and 0 plus 2 would give me 2. So h of 0 is equal to 1 squared is just 1 times -1 times 2, and that's going to give you -2. So the point is at x is 0, y is -2, and the y-intercept is at -2. So let's go to our graph, and let's put in a y-intercept of -2. Okay, so again, first thing when you're given a polynomial function, figure out what the x-intercepts and what the y-intercepts of your graph are. Then we're going to figure out the next 2 things we're going to do is we want to know what the end behavior of our graph is, and then we want to know what's going to happen at each 0. So what's the behavior at each 0? Is it going to cross through? Is it going to be tangent? Or is there going to be a point of inflection? So let's deal with this 0 first. So that 0 was x was equal to -1. If I go back up, I'm just going to erase this. At -1, the 0 had a multiplicity of 2. So at x is equal to -1, it has a multiplicity of 2. And remember, if you have a multiplicity of 2 or multiplicity of 4, our graph is going to be at this x-intercept, it's going to be tangent. So it's going to approach -1, touch it, but not cross it. That's what the word tangent means. Okay, the next zero. So the next zero was right here as a zero of 1. So this zero here has a multiplicity of 1. So x is equal to 1, has a multiplicity of 1. And remember, when you have a multiplicity of 1, what happens is your graph cuts through that 0. So it cuts through it. The last 0 that we have to deal with is this guy right here. So the 0 is at -2. It has a multiplicity of 1, which means at -2, it's going to cut through. So multiplicity of 1, it's going to cut through. Okay, so now we know the end behavior. So when we're drawing out this graph, I'm going to be looking at the end behavior, or sorry, at the what the behavior at each 0. So at 2, I'm going to make sure it's tangent. So sorry, x is equal to -1. I'm going to make sure it's tangent. It's not going to cut through this. At x is equal to 1 and x is equal to -2, these two, I'm going to make sure it cuts through. Okay, we want to know the end behavior of this graph. And remember that the end behavior is given by the degree of the polynomial function and the lead coefficient. So the degree of this polynomial function is 2 plus 1 plus 1, the 4th degree polynomial function, and there's a positive lead coefficient. So let's write down, so 4th degree polynomial function with a positive lead coefficient. What you need to get from 4th degree is it's even. So it's an even degree, positive lead coefficient. The end behavior is the left arm rises and the right arm rises. So on this graph, the left arm is going to rise and the right arm is going to rise. Okay, so this graph, it is going to go through -2 and it's going to cut through it. So I'm going to find -2 and it's going to cut through. So we're going to take this graph and I'm going to just straighten it up a bit. And then we're going to verify on our calculator. So we know that my graph is going to come down and it's going to cut through -2. That should be going through -2, but that's okay. And then once I get to -1, it is tangent. So here's my -1, 0, it's tangent. So that means at -1, it touches it, but it does not cross. It's going to go through my y-intercept of -2. And then what has to happen over here is it is going to, at x-intercept of 1, it is going to cut through. And that would be my graph. What you could do to verify this is we could graph this on our calculators. So on our calculators, let's type in that polynomial function. So it was x plus 1 squared. And then x minus 1 was the second factor. Third factor was x plus 2. I'm going to do a zoom 6 because I changed my window with a previous example. So this is my graph here. The end behavior, the left arm and the right arm both rise. Here's my -2, it cuts through. Here it's tangent, that's my y-intercept. And here it's cutting through the x of the 0 of 1. Remember, to get zeros, you could always get that from your table. So I've got a 0 of -2, I've got a 0 at -1, and I've got a 0 of 1. To get the y-intercept, that would be second function calculate a value when x is 0, y is -2. Okay, the next example that I want you to find is It's actually on the previous slide for me. So it's this one right here. So class, it says question number 3. So let's do, okay, so after you found this class example, we'll start with A first. So this polynomial function here, remember you need to be able to get the zeros of it, and you need to be able to get the y-intercept. So that would be the first question, or sorry, that would be the first step. So from this factor here, we have a 0 of -1. So I'm going to write x is equal to -1. And then right now, I'm just going to say what the multiplicity of that is. So the multiplicity of that is going to be 4. And multiplicity of 4, multiplicity of 2 or multiplicity of 4 is going to be tangent. So remember, it's going to touch the graph at -1, but it's not going to cross it. The second x-intercept would be this guy here, which is an x-intercept of 2. So x is equal to 2, so the 0 is 2. And this has a multiplicity of 1. Multiplicity of 1 means the graph is going to cut through it. Let's figure out what the y-intercept of this graph is. So the y-intercept, you're going to let x equal to 0. So you're going to algebraically find f of 0. So f of 0 means into your function, you're going to put, anytime you see an x, you're going to put in a 0. So that is going to give us 0 plus 1 is going to be 1 to the power of 4 times -2 to the power of 1. One to the power of 4 is just 1 times -2. The 0 at this function is going to be at -2. Sorry, not the 0 of the function, the y-intercept of the function. So I'm going to have a point as well that my graph is going to cut through at 0, -2. The y-intercept is equal to -2. Okay, let's put in those x-intercepts and that y-intercept. So I've got an x-intercept of -1, and I've got an x-intercept of 2. So I'm going to put a dot at -1 and at 2. Now I'm going to put my y-intercept in. My y-intercept is -2. So I'm going to put that in. Okay, so step 1 was always find your x and your y-intercepts. Step 2, we've already done. It's talking about the behavior at the zeros. So at this 0, we're going to be tangent. At this 0, we're going to cut through. Now, I don't know if I'm rising here or if I'm falling. So what I need to do in order to figure out that is I need to figure out the degree of this polynomial function and the leading coefficient. So going back up here, if I was to erase this, this is going to be a 5th degree polynomial function. So 5th degree, which means it is odd. And the leading coefficient is positive. So a graph that is a odd degree, leading coefficient that's positive, the left arm falls, and the right arm rises. So that means that the left arm falls and the right arm rises. So it's going to look something like this. Okay, now I've got to figure out at the zeros, so this 0 and this 0, is it going to cut through or is it going to be tangent? What's going to happen? So at -1, I would go, and I've got a multiplicity of 4, which just means tangent. So my left arm, I don't know if I said it incorrectly, but the left arm is going to fall. But when it gets to -1, it is going to touch it, but not cross it. It's going to come down, and it's going to cut my y-intercept. And then at 2, so right here, it has a multiplicity of 1, it's going to cut through. And I'm just going to erase this guy because I'm going to continue my graph to look like that. And again, this is doing, like when you guys get really good at this, you could do it without using a calculator, but if you can punch this into your calculator, you always want to have it punched in so that you're going to be more precise with your graph because you want to be as precise as you can. The reason why I didn't graph it first is because you really just want to have an understanding what's happening at each graph or what's happening at each zero, the end behavior, the behavior at the zeros. You want to be able to do that. So again, if I was to graph this, let's clear that. And let's type in, the first factor was x plus 1 to the power of 4. So that was the multiplicity of 4. And then the second graph was, or sorry, the second factor was x minus 2. And this guy has a multiplicity of 1, which I don't need to do, but I'll just put that in. So we'll graph this, and that's what it looks like. So that's our -1, 0 here, and its tangent. Here is my 0 of 2, it cuts through. If you wanted to see this like a bit cleaner, I'm going to change my window to go to -3 to 3. So let's see if that makes it look a bit better. Yeah, so that's what it looks like there. This is falling, this arm is rising. The y-intercept is going to be -2, and if you wanted to double check the zeros on your calculator, there's my 2 zeros. X-intercept of -1, x-intercept of 2. Okay, for this one here, let's sort of do the same thing. So let's look at this graph, and first we're going to get the x-intercepts. So I want you to sort of pause this video to see if you could do this part. So get your x-intercepts, algebraically get your y-intercept, figure out the behavior at each 0, and then see if you could figure out the end behavior of this graph. So pause this video for a couple of minutes, do that, and then you can unpause the video to get the answer. So we have x is equal to -1, multiplicity of 3, and that is going to be a point of inflection. So I'm just going to do POI. So at -1, we're going to have a point of inflection. Whenever you have a multiplicity of 3 or 5, we're going to have a point of inflection. My next x-intercept that you should have gotten was x is equal to 3, multiplicity of, let's have a look, 1. Anytime we have a multiplicity of 1, our graph cuts through the behavior of my graph at those zeros. Okay, the y-intercept. We're going to algebraically determine the y-intercept by letting x equal to 0. So in our function, every time you see an x, you're going to input a 0. So we had a negative, and then we'll have 0 plus 1. So I'll just show you up here. I'm going to put a 0 here and a 0 here. So I'm going to have 1 to the power of 3 and -3 to the power of 1. So negative, I'm going to have 1 to the power of 3 times -3 to the power of 1. I don't need to put that 1 there. But g of 0 is equal to -1 times -3. 2 negatives make a positive. I have a y-intercept of 3. So the point of my y-intercept is going to be x is 0 and y is 3. Y-intercept is equal to 3. Now that I have that, I'm going to go put that on my graph. So I'm going to put in my 2 x-intercepts and my y-intercept. So x is -1, x is 3. And then Okay, lastly, before we punch this into our calculator, to sort of get the picture to make it a little bit nice, we are going to figure out the end behavior of my graph. So in order to do that, we need the degree of this polynomial function. And the degree of this polynomial function is going to be 3 plus 1. It is a fourth degree, which is an even polynomial function. The leading coefficient is negative. So negative lead coefficient. What you have to just memorize for an even degree polynomial that has a negative lead coefficient is the end behavior of the graph. It's going to fall on the left and it's going to fall on the right. So this graph is going to fall on the left, fall on the right. Then I know, so let's talk about it. Before we graph it, we're going to punch it into our calculator. Here's my -1. It's going to have a point of inflection. So I've got to do that concavity thing, changing my concavity there. Then at 3, it's going to cut through. So it's going to be straight here, and there's going to be a point of inflection there. So instead of just drawing it, let's look at the actual picture of the graph. So we have negative. The first factor is x plus 1 cubed. And the second factor was, it was x minus 3. I changed my window, so I'm going to do a zoom 6 standard. So there's my graph right there. Here you could clearly see the point of inflection. Here it is going through 3, and then I've got a maximum up here. If you wanted to see the graph up there, we could change our window a bit. So this is going up to 10. Let's go up to 30. Let's just take a guess. So let's go to window, and let's change our Y max to 30. And see if this does. I usually would change my scale factor to 3, but let's not. And yeah. So point of inflection, there's my Y-intercept at 3. There it is cutting through at 3. So now I could sketch this. So what's happening, I'm just going to remove my end behaviors so that I could try to draw this as a continuous function. So here it has to have a point of inflection. Here it cuts through. Okay, super shaky, but that's fine. And that's what my graph would look like. Okay, the next slide I want to do, so the third example we're going to do is going to be this slide here. And this question and then the last one, they are on the last sort of concept that you need to be able to understand. And that is going to be where the value of our polynomial function, the leading coefficient is not 1, okay? So we generally have a leading coefficient. We always have a leading coefficient. So the leading coefficient, how we normally write it, is it's usually an A value, and we put it in front of our factors. And in this example, the A value would be equal to 1, okay? If I went to these examples, I could put an A value there and an A value here. My A value for this one, the A value is 1, and here the A value would be equal to -1. What we're going to do in these last two examples is we're going to figure out what the equation of a graph would be when A is not equal to 1. So what that means is that we're going to do some extra steps to figure out when A is not equal to 1. So a couple of things that we're going to do in order to figure this out. So this is actually a diploma question that we're going to do. So it gives us a graph of a polynomial function. And what it gives you from this polynomial function that I need you to see is it gives you an x-intercept here of -6. It gives you an x-intercept here of -2. it gives you an x-intercept here of 2. When you have x-intercepts of a polynomial function, you could easily get the factors of the polynomial function. So for example, this x-intercept is -6. The factor to get that would be x plus 6, right? It cuts through. I know this is going to be a degree of 1. This graph here, or sorry, this x-intercept here, the factor that gives you that x-intercept to get a 0 of -2 is going to be x plus 2. This last x-intercept is going to be, the 0 is 2, so the factor is x minus 2. Now, this one I know is a degree 1 because it cuts through. This guy here, I know it's a degree 1 because it cuts through. This one is tangent. Tangent is either going to be a degree 2 or a degree 4. But if I scroll down here, the question actually tells me that all the multiplicities must add up to 4. So this was my degree or multiplicity of 1, multiplicity of 1. Therefore, this 0 here must have a multiplicity of 2. So I must have a multiplicity of 2 there, okay? Because now my polynomial function, the degree is 1 plus 1 plus 2. It is a 4th degree polynomial function. I'm just going to get rid of these 1s here. Okay, so now what you do, once you have this written out, they want eventually my answer to be in expanded form, or they've got this in expanded form. But what we're going to do is you're always going to, when you get x-intercepts, you are always going to write it in factored form. They want this polynomial function to be called f of x. And then what you're going to do is they want the value of a. They want what this is. We cannot assume that a is 1. We can't do that. So I have to put an a here, and we're going to figure out what the a value is. Okay, so when we do all these types of questions, you set up your factors, make sure that you have your multiplicities, and then you always put your a value in there. We're going to calculate what the a value is. In order to get this a value, what we are going to need is a point on my graph other than these zeros, and they give you a point right here. So the point that they give us is 0,96. What I could do to this equation here, and actually I'm going to rewrite f of x to be y. Y is equal to, and I'll show you why I'm going to do that. I'll change it to f of x at the end. Okay, so I know what my factors are. I need to figure out what a is. In order to get a, I need to have a point where I can put in x and y. Here's my point right here. X is 0 and y is 96. So what I'm going to do is I need to put in, for my y, I need to put in 96 is equal to a. I don't know what a is. That's what I'm calculating. And for every single x, you're going to put in 0, right? Because they want x to be 0. So 0 plus 6 is 6. 0 plus 2 is 2. 0 minus 2 is -2 squared. We could now figure out what a is. So I have 96 is equal to a times, okay, we got to do a bit more work. 6 times 2 times -2 squared is 4. Then I have 96 is equal to 6 times 2 times 4. That's going to give me 48. Let's just double check. 6 times 2 is 12. 12 times 4 is 48. So I'm going to write, instead of a times 48, I'm going to write 48a. And now I could solve for a. So in order to get a, I divide this side by 48, and I divide this side by 48 to isolate a. And a is equal to 96 divided by 48 is 2. So my a value in my polynomial function is going to be 2. That's going to be my a value. So I could either put the 2 here, or if I expanded this out, there would be a 2 there. So the answer for this question is B. Okay, to see if you get this, and you guys, you might want to star this. This is absolutely going to be an exam question. So I forget if this is on your chapter test or your unit exam. It's on one of the two. Okay, we're going to do the same type of question. So what it says is a cubic function has zeros of 2, -3, and -1. So from there, you're going to write the factors of this function. So the zeros, or the x-intercepts, are x is 2, x is 3, x is -1. If you know what the zeros or the x-intercepts are, you could easily figure out the factors. So I know that to get a 0 of 2, my factor would be x minus 2. In order to get a 0 of 3, my factor would be x minus 3. In order to get a 0 of -1, my factor would be x plus 1. I don't need to figure out the multiplicities of any of these because right now I've got ones here. 1 plus 1 plus 1 is 3, and it tells me it's a cubic function. So all of these have a multiplicity of 1, okay? Let's write y is equal to, and then remember, we can't assume if they don't give us the equation, we can't assume that the a value is 1. We're never allowed to do that. So we always put in a, and then they have to give you a point in order to figure out a. So then I'm going to look in the question, and it says the y-intercept of this graph is -18. So what that means, the y-intercept of this graph is -18. It means that the point when x is 0, y is -18. That would be your y-intercept when x is 0. So here's my point. I've got an x, I've got a y. I could put in zeros for my x, -18 for my y, and then I could isolate a. So y is -18 is equal to a, and then I've got to put in 0 here. So 0 minus 2 is going to give me -2. 0 minus 3 is going to give me -3. 0 plus 1 is going to give me 1. -18 is equal to a times -2 times -3 is 6, and I'm just going to rewrite this as -18 is equal to 6a. Divide this by 6, divide this by 6. A is equal to -3. So now I could go back to my graph, or sorry, to my equation here. I'm going to erase this, and I'm going to put in my -3. This is the equation of my polynomial function. You could keep it in the form of y because I don't specify, right? So if I don't specify, you could say y is equal to, you could have said, if you wanted to, because we know it's a function, you could have said f of x is equal to on a test and then this, or you could have even said, because we know it's a polynomial function, p of x is equal to. If I don't specify, I will allow either one. For a question like this guy, if this was a long answer question, you must have f of x. Okay, the last part of this question was to do a quick sketch of this graph. So to do a quick sketch of this graph, and I will give you your homework, put your zeros in first. I got a 0 of 2, 3, and -1. So -1, 2, and 3. Okay, next we're going to put in the y-intercept, and the y-intercept is -18. So what I'm going to do is I'm just going to put a line down here. I'm going to put point, and I'm just going to say that that's negative 18. Okay. And then the last thing I'm going to do is let's see if we could figure out the end behavior. We know that the behavior at each 0 is going to cut through, right? But let's see if we could figure out the end behavior of my graph. So based on this is a third degree polynomial, which is odd. Lead coefficient is negative. What was the end behavior for a graph that is odd? Leading coefficient is negative. The graph rises to the left and it falls to the right. So it's going to look something like this. To figure out the picture of the graph, and the reason why I did this is because I know it's going to cut through each 0, right? So it's going to come down, go through here, it's going to go up, it's got to cut through this, and then come down. So to actually get the picture, let's put it on our calculator, just so that we can see what this looks like. So y is equal to negative 3. We had x plus 1 was one of our factors. We had x minus 2 as another factor. And we have x minus 3 was the last factor. I'm going to do a zoom 6, though I'm going to have to change my window because I won't be able to see my y-intercept. So there's my graph there. It gives me a really good idea. If we want to see the y-intercept, we know it's at negative 18. So maybe let's go down to negative 20. Y min, negative 20. Yeah, so there's our graph there. Sorry, I just need to see that one more time. So it comes down, cuts through. Okay. It's going to look something like this. Ugh. Okay, you would never do that on a test. Like, you'd fix that. But yeah, that's what our graph would look like. Fix that little squiggly line, make it nice and rounded there, and that would be your graph. Okay, here's your homework questions. I think I assigned questions 10 to 14 in the last lesson. So if that's not done, all of your podcasts up to 14 should be done right now. You've got 2 lessons in the workbook. So I believe this corresponds to lesson 9, and this corresponds to lesson 10. And then because this is the last lesson that you need to do, these are the practice test questions that you need to do for this chapter.